ఈరోజు ఒక 2 క్లాస్ తీసుకుంటే అయిపోతుంది. ఇది కూడా గ్రీన్ కెమిస్ట్రీ ఉన్నాయి. 14 పేజెస్ ఉన్నాయి మనకంతే. సీన్ సార్ క్లాస్ తీసుకుంటున్నాను అన్నారంట. సారు క్లాస్లో జాయిన్ అయిన వాళ్ళు ఎవరైనా ఉంటే సార్ 250కి తీసుకుంటానన్నారు. క్యాన్సిల్ చేసుకొని ఇక్కడికి రమ్మని మీ ఫ్రెండ్స్ ఉంటే. Okay, coming to our green chemistry. So generally the green chemistry build in 12 basic principles. So the 12 basic principles are very mandatory for the green synthesis. So these are some of the basic principles of green chemistry. So these are some of the basic principles of green chemistry. The green chemistry reaction should follow these 12 principles. Mustly follow those 12 principles. So that is the basic principle of green chemistry. So here we will discuss one by one. So the first one, prevent wastage. So in chemistry, every reaction we are getting reactant plus catalyst, or we are adding some of the temperature or pressure. So whatever it may be, finally we are getting the products. In this green chemistry, we are getting the only selective products only, not only byproducts. So that's why we are using prevent the wastages. That means we can produce less percentage of the byproducts. So the reaction must be in atom economy. So that means it is 100 percentage of desired product. It gives 100 percentage desired products. For example, in case of Diels-Alder reaction, we are getting 100 percentage desired product of cyclohexene. So that is atom economy. So what is the desired product? We are getting 100 percentage. For example, if you take the reactant mass, how much mass of reactant, how much mass of product. So that is the equal percentage of the product we are getting. So this is the atom economic. So in this synthesis, so it is a very less hazard synthesis. That means we are getting the some of the products or byproducts. It may be not hazards or less hazards. So that is one of the principle of green chemistry. Design beginnings chemicals. We take initial chemicals, like if you take the not intermediate chemicals, we are taking the initial chemicals to prepare the products. Like if you take the glucose we can prepare from starch only. So starch it is a naturally available compound. So in potatoes, so many compounds we are getting in naturally. So that's why. So we are from we take from this beginning chemicals only. The glucose we are preparing. So beginning solvents and auxiliaries. So we also use beginning solvents. If you take simple reaction starch, so what is happening? So under hydrolysis, finally we are getting the glucose. So this is a purely um, um, the no harmful chemicals we are using, because of H2O it is a purely water. So after the hydrolysis process, starch will give the glucose. So that is one of the example of this reaction. Design for energy efficiency. So we are using less energy for these reactions. So many reactions under the conducting in microwave assisted synthesis and sonication reaction, also some cases we are using less energy to get the product. Because of we are using less energy for this reaction, the energy consumption also one of the environmental pollution. So that's why we are using the less um, energy efficiency reactions. Use of renewable feedstocks, like renewable feedstocks. If you prepare a protein amino acids from protein chain, like we take from protein chains to prepare the amino acids. So the protein chain we are getting in naturally, so that's why we are getting so many amino acids from this. So use of renewable feedstocks, so that is also one of the the eighth one, reduce derivatives. There is no derivative. So for example, if you prepare phenol, so we are selectively prepare para-bromophenol, not to prepare the meta and ortho bromophenols. So that is main derivatives. We can reduce the derivatives only. So we are selectively prepare the one of the selective compound. So para-bromophenol only. And some reactions are we are using catalysis process also. So the catalyst also must be in stoichiometric ratio. Why are you using catalyst? Catalyst ఎందుకు యూజ్ చేస్తాం మనం జనరల్లీ? Catalyst ఎందుకు యూజ్ చేస్తామండి? In reactions we are using catalyst. Hello. So the use of speed there, that means we can reduce the activation energy the reduce చేస్తుంది. After that the reaction will be speed up అవుతుంది. So that's why we are using the catalyst. And design for degradation. So after we are getting the product, so it should be degradation product. So that means there is no harmful to the environmental. For example, if you prepare the polythene covers like, so the polythene covers, there may be HDAP, main high density polymers. It is a degradable, but in the less LDEP, low density polymers, it is a very harmful, does not degradable in the soil. It's take more time to when compared to HDEP. So that's why we are using always this design for the degradation products also. And the 11th one, real time analysis for pollution prevention. So that means we real time mean what is the real time? So the reaction time. So that is the real time. For example, we are conducting a reaction in 8 hours. So that is the real time of the reaction. So that's why we can reduce the real time also, first of all. So in magnetic stirrers like reflex, round bottle reflex, we are conducting this reaction which take more time, but in the same reaction we done in less time at microwave assisted synthesis and sonication reactions. So that's why we can reduce the time also, real time also. And the if you reduce the real time, so automatically the pollution also control and prevention. So because of there is no pollution is there, and the reaction is very uh, done in the few minutes only. So the 12th one, uh, so we can prevent the accident also. So the everyone know about the laboratories, what are the chemicals used in the laboratory, which chemicals are harmful, which chemicals are hazards. We can prevent every time. We can training the staff of the staff, and then after we can prevent this um, accident preventions also. Everyone aware about this accidents happen in this staff. For example, if you take the any pharmaceutical company, so there is a one person done the mistake, so there is a very so what is happening, it is accidentally. So loss of the chemicals and pollution also very increases. So some of the human beings also die. So that's why every person know about the accidental precautions. So this is about the 12 principles of the green chemistry. So the next one, this is also we can simply um, uh, waste of prevention. This is also same thing. Atom economy, less hazards, chemical synthesis, design safer chemicals and safer solvent auxiliaries, and design for energy efficiency, use of renewable feedstocks, and reduce derivatives. And ninth one, catalysis, design for degradation and real-time pollution. So ఇది అయిపోయింది ఆల్రెడీ. ఇంకా so Diels-Alder reaction, it is one of the example of atom economic reaction. So what is the equation of atom economic reaction? So the atom economic reaction, so this is the equation of atom economic reaction. So the atom economy, the mass of atoms in desired product. So what are the product we are preparing? That is the desired product. What are the product we are preparing? That is the desired product. For example, in case of which one? For example, if you prepare like Diels-Alder reaction, that is the cyclohexane is the desired product. Cyclohexane is the desired product. So there is no byproducts are present in the reaction. So this is the equation we are using. Atom economy, it is equal to mass of atoms in desired products by mass of atoms in reactants. Mass of, so ఇది మీరు కొంచెం గుర్తుంచుకోవాలి ఈ ఈక్వేషన్. ఆటమ్ ఎకనామీ ఈజ్ ఈక్వల్ టు మాస్ ఆఫ్ ఆటమ్స్ ఇన్ డిజైర్డ్ ప్రొడక్ట్స్ బై మాస్ ఆఫ్ ఆటమ్స్ ఇన్ రియాక్టెంట్స్ ఇంటూ 100. For example, some of the examples of reactions is here. Like for example, if you prepare the methane combination reaction, so we take methane combination reaction. So what is happening in non-combination, methane gives water plus carbon dioxide. So what is the molar mass of methane? Molar mass or molecular weight of methane. So here in methane, molecular formula CH4, 1 carbon 12, and the hydrogen atomic mass 1. 1 into how many hydrogens are present? 4. So totally 12 plus 4, 16. So here O2 is the oxygen molecule, not atom. The atomic mass of oxygen is equal to 16 atomic mass. So here O2, how many oxygens are present in O2? 2. 16 into 2, and that is equal to 32. But here we take the 2 moles of O2. 2 moles of O2. So that's why we can write into 2 into 32 is equal to 64. This is also same thing. And water molecule, the molar mass of water molecule, how many hydrogens are present in water? 2 hydrogen, 1 oxygen. The atomic weight of hydrogen 1 and the oxygen 16. So here one of the H2O, how many hydrogens are present? 2 hydrogens. 2 plus 16 is equal to 18. So the molar mass of H2O is equal to 18. So here how many moles of H2O we are getting in product? 2 moles. So that's why 2 into 18, 36. So if you have prepared the water from methane combination reaction, for example, if you prepare the water molecule from methane combination reaction, what is happening? So we take 16 grams of methane and the 64 grams of oxygen. It produces 36 grams of the water molecule. So how much reactants we are using? What is the mass of reactants we are using? So we are adding the 16 grams of this one, first one, 16 grams of methane and 64 grams of oxygen, total 80. So that is equal to 80. Finally we are getting product. What is the mass of product? 36 by 80. So after the divided 36 by 80, finally we are getting 45%. So this reaction is not atom economic reaction. Because of atom economic reaction, we are getting the 100% desired products, only desired products. If you prepare water from this combination reaction, this is not good reaction. So that's why it is not a atom economic reaction, it is not a green chemistry reaction. So we can prepare from other resources. um, CO2 also we can, for example, if you take the desired product of కార్బన్ డైఆక్సైడ్ కూడా చేయొచ్చండి. మనం వాటర్ అనేది డిజైర్డ్ ప్రోడక్ట్ అనుకున్నాం కాబట్టి వాటర్ చేసాము. ఇఫ్ యూ టేక్ కార్బన్ డైఆక్సైడ్ యాజ్ ఎ డిజైర్డ్ ప్రోడక్ట్, యాజ్ రిష్, అది కూడా క్యాలిక్యులేషన్ చేయొచ్చు. ఫర్ ఎగ్జాంపుల్ యూ కెన్ ప్రిపేర్ ఫ్రమ్ దిస్ కంబైనేషన్ రియాక్షన్ వీఆర్ ప్రిపేరింగ్ కార్బన్ డైఆక్సైడ్ అనుకోండి. సో దట్ ఈస్ ద పర్సంటేజ్ ఈజ్ డిఫరెంట్. దాంట్లో అది కూడా మీరు అనుకొని చేయొచ్చు, ఏం కాదు. ఎంత వస్తుందండి ఇక్కడ? ఒకవేళ అయితే ఇది 45 వచ్చింది కాబట్టి రిమైనింగ్ ఇది ఉంది కాబట్టి 55% ఆఫ్ డిజైర్డ్ ప్రొడక్ట్ వస్తుంది. సో అంటే ఇది మాత్రం 100% ఆటమ్ ఎకనామిక్ రియాక్షన్ కాదు. బికాస్ ఆఫ్ ఇన్ ఆటమ్ ఎకనామిక్ రియాక్షన్ వీఆర్ గెటింగ్ ఓన్లీ వన్ ప్రొడక్ట్ రావాలి. సో దెర్ ఈజ్ నో బై ప్రొడక్ట్స్. ఇఫ్ యూ గెట్ బై ప్రొడక్ట్స్, దట్ ఈస్ ద లాస్ ఆఫ్ desired product concept. For example, here CO2, we can take CO2 44. So molar mass of CO2 44 by 80. Finally we are getting 55% వస్తుంది. అది ఒకవేళ మనం అది ఏంది CO2 డిజైర్డ్ ప్రోడక్ట్ అనుకుంటాం. సో అది అది అవుట్ ఆఫ్ ఇష్యూ. ఓకే, నెక్స్ట్ so some of the types of atom economic reactions. So here we take isomerization, rearrangement reactions, or addition reaction. These three reactions are atom economic reaction. First of all, consider as a atom economic reaction, isomerization and the rearrangement reaction and addition reaction. So these three reactions are atom economic reaction. So this is the second part, and catalytic reactions, use of stoichiometric reagents, substitutions and elimination. So these are all the decreasing of the atom economic reaction. From 100 to here we can less the from 0 to 0% of the desired product. So that's why if you use catalytic reactions of the some of the reagents reactions and substitutions and elimination. So substitution mean we can substitute one of the product by another one. For example, if you substituted nucleophile or electrophile, so that means we can lose the byproducts also. And elimination also, we can eliminate to the some of the atoms from the reactants. So that is also not suitable for the atom economic reaction. So these types of these three reactions are very suitable for the atom economic reactions: isomerization, rearrangement reaction, green sensing. Because of this reaction, the two scientists they are um, don't use any energy resources also. They are conducting this energy under photochemical condition. So that's why this reaction is purely atom economic reaction. So we know about this scientist. The first one, Otto Ermin Diels. So he was from Germany. He is fellow scientist Kudju Adler. So he one of his student Kudju Adler. So they got Nobel Prize for this reaction in 1950. Okay, simple reaction ki వాళ్ళకి Nobel Prize రావడం జరిగింది. So after that, so many scientists are involving in this green synthesis. So next one, so what are the solvents we are using in green chemistry? Green chemistry, what are the solvents are we are using? So generally we are using so some of the solvents are here. First of all, what are the conditions involving in the green chemistry principles? The principles based on principles, whatever it may be, we are using solvent, so it is less hazardous, or maybe it is no harmful to the environment. So that's why so many green chemistry reactions conducted under the water is a solvent. Because of water, it does not pollute any environmental pollution, because of it is a purely available in naturally. So that's why we are using so many reactions under the green chemistry reaction. Water is a solvent ga water తీసుకుంటాం. Some cases we are using supercritical fluids and gas expanded liquids and ionic liquids. Some cases we are using liquid polymers also. So these are the solvents we are using because of less harmful chemicals we are using. So the liquid fuel gases like CO2 and DMC. సో ఇది బాగా కనపడట్లేదట్టుంది, ఐ థింక్ ఇంకోటి తీసుకున్నాను. Liquefied gases, that mean we are liquefied the gases. So generally we are getting natural gases. All the natural gases are the in the gaseous state, so we can reduce the temperature, so that gases are after the involving in liquefaction. For example, if you take nitrogen gases, it is available in naturally, oxygen and carbon dioxide also. So it is less percentage in the environmental, but this is also naturally available gases, carbon dioxide. So liquefied the gases, for example, if you take carbon dioxide, so how much temperature we are using? Minus 72 degrees. And if you take nitrogen, minus 196 degrees. So these are the temperatures. So these gases are liquefaction in the form of liquid. So bio-based solvents. So bio-based solvents mean so some of the fatty acids like fatty acids we are getting from naturally. Fatty acids వాటిని కూడా మనం బయోబేస్డ్ ఫ్యాటీ యాసిడ్స్ని వేర్ యూజింగ్. వాటర్ ఈజ్ ద బెస్ట్ సాల్వెంట్ ఫర్ గ్రీన్ సింథసిస్. వాటర్ అయితే 100% ఇట్ ఈస్ ఏ గ్రీన్ సింథసిస్ సాల్వెంట్. Ionic liquids, eutectic solvents, deep eutectic solvents. So these are all the some of the liquids solvents we are using in the green synthesis. So here sonochemistry. So what is the sonochemistry? We are using the sonic spectrum. So in sonic spectrum in reactants, so we are using sonic spectrum to the reactants. After the involving in collisions, we are getting the product. So this is also very important role in the green chemistry. So ఒక నిమిషం. We know about the frequency ranges. సో ఫ్రీక్వెన్సీ రేంజెస్ మీకు తెలుసు జనరల్గా. సోనిక్ సౌండ్స్ అంటే సూపర్ సోనిక్ సౌండ్స్ అంటే వీఆర్ నాట్ హియరింగ్ దట్ సౌండ్స్. ఫర్ ఎగ్జాంపుల్, ఇఫ్ యూ టేక్ ద వెరీ high edge frequencies, we doesn't hear the sound. So that's a type of sounds we are using in this green chemistry synthesis. After that, this conducting this sonication reactions. So generally we are using the ultrasounds in the part of sonication spectrum. We are using 20 kilohertz to 10 megahertz. Hertz means cycles per seconds అండి. హౌ మెనీ సైకిల్స్ ఆర్ ఇన్ ఫ్రీక్వెన్సీ. జనరల్గా వేవ్కి ఎన్ని సైకిల్స్ తిరుగుతుందనే దానికి యూనిట్స్గా తీసుకుంటాము. 20 కిలోహెర్ట్జ్ నుంచి 10 మెగాహెర్ట్జ్ వరకు వీఆర్ యూజింగ్ అల్ట్రాసౌండ్స్ని ఉపయోగించి. సో ఇంకో కండిషన్ ఏంటంటే at the same time we are using temperature and pressure also very high. So pressure and temperature also we are using very high. So this time what is happening, the pressure and so generally these are the um, common human beings are hearing ranges from. So what are the decibels? Here we take the decibel ranges from, so which sound is how much decibel. The breathing from 10 decibels. So these are the some of the హ్యూమన్ హియరింగ్ రేంజెస్. సో ఇది మీకు తెలిసిన విషయమే, ఇది దీని గురించి మనం ఇప్పుడు అవసరం లేదు. ఈ సోనికేషన్లోనే సో వాట్ ఈజ్ హ్యాపెనింగ్, సో దిస్ ఈజ్ వీఆర్ కంప్రెషన్ ద వేవ్ని ఏం చేస్తాం మనం, కంప్రెషన్ చేసి ఆఫ్టర్ దట్ సౌండ్ని వీఆర్ యూజింగ్ హై టెంపరేచర్ అండ్ హై ప్రెజర్ ఆల్సో. ఎప్పుడైనా మనం ఏదైనా కంప్రెషన్ చేయాలంటే సో వీఆర్ యూజింగ్ హై ప్రెజర్. సో ఇయర్ we can use 2000 atmosphere pressure and temperature. So temperature we are using 5000 degrees. At that time the wave will be compression. So it is a bubble form generally. So after this bubble form to reach the unstable size. So when we are using this temperature and pressure, the wave reaches is unstable size. So this wave unstable size after the beat the reactants. So finally the reactants involving in collision process. So this is take a very less time when compared to normal manual reactions take more time, but this sonication reaction we are using less time. Because of this reason we are using the wave very compressive rate. So తలకాయ తింటారు ఆయన మీరు. Very compressive rays. After that this compressive wave involving in the reaction mixture. So what is happening, the reaction mixture, it's reached to the reaction mixture. So finally so the reaction mixtures reactants involving in the collision process, we are getting the products. So this is happening when the wave will be reaches to the reaching to the reactant mixtures. సో దాని గురించి మనం రేపు డీటెయిల్స్ చెప్తున్నాం. టైం అయిపోయింది. రేపు 9కు ఏమైనా క్లాస్ ఉందా మీకు? 9కు. హలో, సరే దానికన్నా ముందు ఏముంది మరి? 8:20కి అట్లా ఉంటుందా క్లాసు? 2:50కి ఉంది కదా మార్నింగ్. అంటే రేపు మరి వేరే వర్క్ ఉంది మళ్ళీ. ఎప్పుడు ఖాళీ ఉంటుందో మరి మీకు? ఎప్పుడు ఉంటుంది ఖాళీ? 8:20కి పెడదాం. 8కి పెడితే కొడతారు జనాలు. సరే, ఓకే, థ్యాంక్ యూ.